Great. Okay, so I will get started then. All right, you guys are seeing the slides okay?
Yeah.
All right, great. Yeah, so just a little background, and you guys can cut me off at any point, ask questions. I'm happy to be interrupted. What I'm going to do is try to kind of run through a little bit of background on kind of spatial factors and health, why we care about these things. I'll go into a deep dive on greenness and mortality, which is the paper I sent you, but I don't want to spend too much time on that. I really want to talk about future directions. Then I want to talk about kind of nature, equity, COVID, and climate change. But if there's anything you want me to go into more depth on, I'm happy to. I know this is not an academic presentation, so I'm not going to make it super methodsy and too dense. So let's just keep it light, and feel free to interrupt me at any time. Okay. So my area of interest is in how the places in which we live, work, and play.
Sorry, Eva had a quick question. I muted you.
Oh yeah, go for it.
I was just wondering, what is an SCD?
What is it?
Oh,
what is my degree?
Yeah, sorry, thank you.
Because we do research on SCD, which is sudden cardiac death, and I was like, I don't know that came up yet, but no, yeah, SCD is so Harvard has some very strange, arcane things, but basically, it used to be that Harvard's only the Faculty of Arts and Sciences could give a PhD. So the School of Public Health used to give SCDs, but now you can get a PhD at Harvard too. So it's just a function of how old I am and when I got my doctoral degree at Harvard. But yeah, it's basically a PhD.
Okay, great, thank you.
All right. So I study how the places in which we live, work, and play influence our behavior and ultimately our health. This research, and you guys may be kind of familiar with this concept of the ecosocial model, where individual choice drives health. So like the choices that we make drive our health outcomes, but also these decisions are made within a context, right? So your context may nudge you in one direction or another, may make it easier for you to make kind of healthier choices. So like where you live might influence your exposure to air pollution. It might influence, whether you walk or drive or bike or take the bus to get from place to place. Might influence your access to healthy foods and your access to safe, inviting parks and green spaces close by. And also, obviously maybe these exposures cut across racial and socioeconomic lines in the US, but really globally. So thinking about kind of this dynamic of these different spatial factors and how they kind of push us towards different health outcomes is what I study. I think, and I don't have the time to get into all of this, but spatial factors that I study are linked to physical activity, sleep, obesity, cognitive function, mental health, which are major contributors to chronic disease risk. What I always say, these are ubiquitous exposures. We're not talking about a rare chemical exposure that only certain populations are exposed to. Really, everyone is kind of, when you walk out the door, exposed to some type of built or natural environment, right? And these are modifiable factors, right? So I have this sculpture in East Boston looking back at downtown Boston saying a city is not an accident, right? On the other side, it says about the result of coherent visions and aims, right? Every single thing you see when you walk out the door is a decision that somebody made, some policymaker, some planner, somebody with money, a developer. These are how our cities are crafted. And it's also how rural areas are not touched, for instance. Now, there are decisions that are made, and these decisions have really long-lasting effects. So you change, you do the big dig and you take a highway and put it underground. That has effects for generations. For everyone who comes to Boston, everyone who lives in Boston feels the effects of things like that. So I really want to think about these different modifiable factors, whether it's through land use policy, zoning, transportation planning, people moving addresses, doing the work that you guys do, right, to change neighborhoods. That is the thing that can kind of modify the health effects that we're talking about, and it has really long-lasting impacts. So, I start when I talk about nature with usually a photo like this, which I call my face validity slide, right? This is just just viewing nature, something about it we enjoy, right? It's something beautiful, something that kind of gets under our skin, right? E.O. Wilson, the Harvard biologist, popularized this term biophilia, that we've evolved with nature to have an affinity for nature. There's something about nature that we inherently enjoy, right? And it doesn't have to be Yosemite, right? It could be the Esplanade. It could be street trees on your block. It could be a houseplant in your home, right? We're not sure what kind of scale of nature really moves the needle, but we do see that, we're not, when we study nature, and I'll talk about this, we're not talking about people going to national parks or going on wilderness adventures. We're talking about incorporating nature into our everyday lives. And that's where we do see kind of the biggest quantity of exposure, the most people getting exposed to nature, and that duration, that time spent in nature. And we see that that's what kind of moves the needle. So, I just want to also give you guys a little bit of theory on how nature affects health. Another way is attention restoration theory. The concept here is that urban environments tax our attentional control. We have to focus on things, and something about being in a natural environment invokes a sense of kind of being away and fascination that kind of replenishes our directed attention, right? So it's this indirect attention, just looking at trees swaying in the wind. Something about it kind of allows us to restore that focus and gets us ready for the next cognitive task. There's also stress reduction theory, and this is just that natural scenes activate our parasympathetic nervous system in ways that reduce stress and autonomic arousal. These type of landscapes can activate our physiology in effectively beneficial ways. So like basically you have positive affect, you're happier even when undergoing stress, and this kind of blocks negative thoughts. And now, of course, my computer, you guys hear me still?
Yeah.
Yeah. And now I'm getting a little spinning wheel here. Shouldn't have put so many videos in this talk. What are you guys looking at right now? Is it still just
It's a beautiful picture. You could just stay on this picture.
Yeah. Unfortunately, I can't see my other slides, but let me stop sharing really quickly and see if we can kill PowerPoint here. This is the first time this has happened.
I just have a question, and now I've forgotten it as you were speaking, but now I've forgotten.
Okay. Well, I can kind of continue talking as we move forward, as I wait for these slides to fix. But basically, we think about kind of four main pathways through which nature affects health that are kind of a little more straightforward. And these are, that spending time in green spaces allows us to have lower exposure to air pollution, lower exposure to extreme temperatures, lower exposure to noise, and that might have independent health effects. There's also, being in green spaces is a setting where you can obtain physical activity. So that's a pretty straightforward pathway, right? Another one is social engagement. So this pathway, you have more trees out, you're more likely to spend time outdoors with your neighbors, and that social engagement has independent health benefits. And then finally, there's this kind of stress or cognitive function pathway. This idea that the direct spending time in nature is related to some sort of health benefits, right? So you spend time in nature, you have lower levels of stress, you have better cognitive function, and that's related to health benefits in the long run. This doesn't seem to be, I'm not sure what's going on. I can't even end the show. So maybe if you're okay, I can just keep going, but I could try and restart my computer. What do you think?
I was going to suggest it. You want to restart your computer, and I don't know what's in your slides. If it feels like it's.
I feel like the slides are helpful because I have lots of images that I think kind of illustrate the point. So let me restart my computer and I'll call back in.
Sure.
All right. Sorry about that. All right. Thanks.
I think I've met him before. He looks so familiar.
He looks so young.
He looks like he's like 8. Yeah. I don't know where I would have been.
So you never answered your question though, what it stands for.
Yeah, you did.
Yeah, it's
No, like PhD stands for philosophical doctorate. Or
Doctor of
Science?
philosophy. It's probably Doctor of Science, right?
science something.
Oh,
You
so
know
that's
your
a
hair.
sudden cardiac.
Yeah.
SCD. That was a joke.
What's that?
That was a joke. That sudden cardiac.
No, it does.
No,
It
that's a
stands for
different
that
thing.
too.
That wasn't
Yeah.
a joke. That was.
But
Oh,
it- But
he was
Eva
like,
was
why are you
asking.
thinking about that?
Eva was asking about after his name, he uses the initials SCD. But So like
Yeah.
I could use the initials PhD after my name, right?
You do.
I rarely do, but
In
I
your
sometimes
email signature, you do.
I do. Okay.
You do. I rarely do.
This is my signature. Okay, it happened
It's
to
a
fall
big
my signature.
accomplishment. It
It
takes
is a big
lot of time
accomplishment,
and
but
work.
I don't introduce myself as Dr. Meshula. That's my dad.
I said that to you in the email. the
I
other
know you did. I appreciate that.
We don't have any doctors in my family.
Yeah,
Anymore. We have.
but you never said what it stood for, those letters.
Yeah, I don't know. I guess it just sounds like
Science
it's
doctor, maybe?
antiquated.
That makes sense, right? Because
Yeah.
like a
EDD.
doctor of education, exactly.
Yeah. It's funny because when he was saying that, my wife was involved in the conversation at Harvard when they were transitioning from an EDD to a PhD for their students. I wonder if it was like an institutional decision.
Also, it's really weird seeing everyone here, there, and a lot.
Well, yeah, it is. And we're like, it's like we're in, is it an IMAX theater? Where they have like the screens all around you.
Oh, yeah.
Oh, yeah.
Well, and then it's all 3 different timings slightly too.
Real time. I'm guessing that's second fastest and that's the third. It's distracting.
I don't know if I can, I guess I could turn off this screen out of it. But just like physically turn off the button.
Oh,
Oh, I should have paused the recording.
that's okay now.
Set of data.
Yeah, exactly.
Right.
All right, can you guys hear me?
Yep.
Yep.
You see us okay?
1 second. The audio is not working for me.
Uh-oh. It's not one thing, it's another. No? Is it us?
All right, can you hear me now?
We can hear you. Can you hear us?
All right, I think I can.
All right.
All right, let's try this again. Sorry about that.
Sorry. Oh, you did.
I did.
Perfect. Thank you.
Yeah, all right, you got, yeah, the recording, I think, started again too. All right, so this is just that figure I was talking about these kind of pathways. So we think about the kind of green space, trees, lower exposure to harmful environmental factors, more physical activity, greater social context, and lower levels of stress and cognitive function. And then each of those pathways could be related to health outcomes. Is there a question?
Yeah, one thing that I noticed that's missing here and also in your paper, and one thing we talk about a lot, and I'm curious to hear what maybe it's a methods issue, is things like heat island effect, right? Those types of ecosystem benefits. When we talk about trees and the relationship to people in Boston, we focus on those types of things. And I don't know if that's the wrong scale.
No, it's a very, very good point. So I kind of lumped those factors into this environmental factors. So temperature, air pollution, noise, we think about green spaces in terms of buffering us from all of those exposures. Now that wasn't in the paper that we published back in 2016 because we didn't have that data then, but we do have that data now. And I'll talk about that in a second, actually. So I just want to run through, actually, this is a nice segue because how do we actually study these things, looking at kind of longer term health outcomes? So what we usually do is we look at large prospective cohort studies, right? So if we want to look at mortality or cancer or cardiovascular disease, we need these studies with long-term follow-up, right? So we have studies like the Nurses' Health Study, 121,000 female nurses started in the study in 1976. These are their geocoded addresses. We've geocoded all of their residential addresses over follow-up since 1986, actually, when we started geocoding. So we have their location where they lived, and we have all sorts of questionnaires every 2 years, and we have disease and mortality follow-up, right? So we use that residential address information to attribute some of these green space exposures to them. And we also look at a lot of other factors. It's worth noting, it's not only the Nurses' Health Study, we have the Nurses' Health Study 2, another 116,000 participants. We have the Health Professionals Follow-Up Study, 51,000 participants. We have the Growing Up Today study. These are children of Nurses' Health Study 2 participants, about 26,000 participants there. We have lots and lots of people that we've been following over time, and we've geocoded their residential addresses. So we use that residential address as a kind of proxy for exposure to nature. I also just want to touch on that. We take what's called an exposomic approach, and this is a very academic, jargony term, but the idea of the exposome is trying to look at the totality of exposures over the life course, as opposed to just reductionist looking at one factor alone. So we look at things like air pollution, we look at things like temperature now. So as was mentioned, we now have temperature data at fairly fine scale. We don't have it at a block to block scale, and that's because we do a lot of nationwide studies, but we could certainly derive some of those measures. This is kind of a 400-meter resolution measure of temperature at the day level. So we have kind of mean, min, max, things like that for temperature at the day level. We also have things like neighborhood walkability, noise, and light at night, among other metrics. And our team is kind of looking at all of these kind of together in concert. So seeing how different pathways kind of influence health and not just one in isolation. So, what does that look like? So we take these geocoded addresses and we kind of overlay. Yep.
Sorry, I have a quick question. I've never seen light at night used in any kind of study like this, and I'm just curious why that, or I guess why that was one of the factors you're looking at.
Yes, so there's a kind of growing research on light pollution and how light pollution could disrupt circadian rhythms, could influence, hormone production. So there's a fair bit of work out there. We publish on, for instance, light at night in breast cancer. Other folks are looking at light at night in prostate cancer. There's a huge body of literature in kind of ecology on how outdoor lighting affects like birds and other animals. So we look at it in terms of similar pathways in terms of circadian disruption and hormone dysregulation. So that's why we think about it as like another kind of component. Now it's highly correlated with a lot of things, right? So the sources of the lights are also a source of human activity, maybe cars, air pollution, noise, other things. So we do have to kind of disentangle that, and that's tricky to do. But it's yet another component of kind of, if you think about even green space, right? You'd expect higher green space and lower levels of light too, right?
Thank you so much.
Sure. So what does this look like? We take our geocoded addresses, which is like about 4 million geocoded addresses over all the cohorts I talked about, and we overlay, for instance, satellite image on green space, satellite image data on green space, right? So I'll talk about how we did that in this paper, in this greenness and mortality paper. So at the time that we published this or started working on this, there were very few studies looking at greenness. So, and I'll talk about why we use greenness and looking at the outcome of mortality. So we wanted to do this in the Nurses Health Study where we had that geocoded address level data and we had follow-up for mortality outcomes. So again, we use this cohort of 120,000 female nurses. We had mortality data on them and their geocoded addresses. And then for our exposure to nature, we used the Normalized Difference Vegetation Index. How many of you guys have heard of that? Okay, so okay, good. So this is a measure, and I'll be talking a lot about it today and its shortcomings, but it's a measure that basically captures the photosynthetic potential of a given area, right? So it's the vegetation scattering near infrared light, keep from overheating and absorbing visible light from photosynthesis. We look at the ratio of the near infrared to visible light, and we can get a good quantitative, objective measure of vegetation quantity in a given pixel. So for this study, we use this MODIS data, which is available at a 250-meter resolution, pretty fine resolution, and it's time varying. So we get it every 16 days at every surface of the globe. So it's a nice measure that we can create a time varying measure of objective vegetation around participants' homes. So how does that work? So this is a hypothetical address. We overlay that data on NDVI, and we can extract the value, for instance, for the pixel that this participant lives in. Or we can do a buffer and say, like, what's the kind of neighborhood average vegetation for the area around this participant's home. So this is our main finding. We basically saw, this is looking at different levels of greenness divided into quintiles, so 20 percentiles. And in the top 20% most green places, we saw about a 12% lower mortality rate over follow-up. So that's what we see. Was there a question? No question. No, I thought I saw a hand raised. Yeah, okay. but basically what we're seeing here is adjusted for individual socioeconomic status and area level, census tract median income and median home value. So it's independent of those factors. Next, we looked at what's called mediation, and this is just a fancy way of saying, what are the mechanisms through which green space might affect mortality? And we accounted for these things because we measured them in these cohorts. So physical activity actually only explained about 2% of that association. Air pollution exposure explained about 4.4%. And it'd be interesting to look at temperature now that we have it and see how much of that that greenness mortality relationship is explained by temperature differences. Social engagement was only about 19%, and actually mental health, which we measured through doctor-diagnosed depression or antidepressant use, explained about 31% of the association between greenness and mortality. So pretty strong, evidence of that mechanism, that kind of mental health pathway, explaining the health benefits of nature on mortality outcomes.
That to me is an astounding result. That mental health, and we rarely talk about that in our work. I mean, it's embedded, but we never profile it. And if that holds, for a more micro analysis, that maybe we should consider, like, that would be something really important for us to profile and think about.
Yeah, I think it's super important. And I think what people don't get, they may get this link, the greenness mental health link, but they don't necessarily get this link, the greenness to mortality link, mental health to mortality link. Mental health is not a fringe thing. It gets under our skin, and it does affect hard health outcomes. I mean, it's important enough on its own, but people don't necessarily get this linkage either. So I think it's worth playing up how serious that is. It's not just a light topic. So, I think since we've done this study, we've done a lot of other research on nature and health in our team. We have some doctoral students and postdocs who are incredible. They're doing work on mental health independently. So we're looking at kind of depression, anxiety. We have an amazing colleague, Marcia Pescador Jimenez, who's now at BU, was a postdoc with our group. She's doing some really cutting edge work on greenness and cognitive function. We have Greta Wilt and Charlie Roscoe, a doctoral student and postdoc, who are looking at kind of minute-to-minute exposure to nature and physical activity and sleep, which I'll talk a little bit about. We have published on birth outcomes. We're working on cardiovascular disease. So there's just a lot of literature, and there's more outcomes than just this. So it's a really robust area of work, and I could send you more. We did a kind of a landscape review for National Geographic recently. I could send that to you as well, where we've really, it's a cross-cutting field. So we're epidemiologists. We come from our kind of public health lens, but there's environmental psychologists. There's tons of groups that are doing this work and looking at it kind of every step along the way through randomized trials. Gina South's group in Philadelphia is doing some amazing work in greening vacant lots and randomizing, where the lots are greened. There's groups in Louisville who are doing work on this as well through the Green Heart Project. So going to be some really innovative work coming out in the near future that are testing, in a purely kind of experimental way, some of these ideas of planting trees and how those trees might have benefits in health outcomes. But I want to talk a little bit about, kind of methodsy stuff, because I think it motivates how we ask better questions. So first of all, NDVI, you guys, most of you said you'd heard of this term. Is greenness around the home the right measure? So first of all, what area around the home are we talking about? Are we capturing contact with or exposure to nature, or just some sort of like poor metric for access to nature? We also focus on vegetation, this vegetation index, but what are the specific active ingredients in nature? Like, what are the active components? And that's not really a light question. This is really a question that limits our causal inference. And that sounds very academic, but basically what that means is we don't know what to tell policymakers to do to change outcomes, right? So how do you increase NDVI by 0.1? Do you plant trees? Do you plant grass? Do you build parks? We don't know the answers to those questions, and therefore we're still somewhat limited in what we can tell a policymaker. Like, we're very confident this is the truth, right? So that's what we're working on in our future direction. So first of all, we define exposure. I've kind of talked about this. We define exposure are on these residential addresses of our participants, but we know from time activity studies that people spend less than 50% of their time actually at home. So we know we have lots of error in that measure, right? So what we've been doing is in the Nurses Health Study 3, yet another iteration of our Nurses Health Study cohorts. This is about 50,000 nurses and nursing students. They're 19 to 46 years old, based across the entire US. You can see the map of where they live there. They fill out web-based questionnaires every 6 months. And that we noticed that they were opening their study emails predominantly using smartphone operating systems, right? So we thought this is a pretty good cohort to implement some mobile health technologies. So we ran in 2018 to 2020 this Nurses Health Study 3 mobile health sub-study. We had about 450 participants. We sent them a Fitbit and asked them to download a custom smartphone app. And then we asked them to wear the Fitbit for 7-day sampling periods, 4 separate times across the year to get some seasonal variability in their behavioral patterns. You know, how many people have worn a Fitbit or worn a wearable device? Yeah, a few people. So yeah, so these devices measure steps, heart rate, and sleep at the minute level. They're actually pretty valid when compared to the kind of gold standard measures. So they do perform pretty well. Our app measured location and administered very short questionnaires. And when I say location, we're measuring location basically every 10 minutes. We ping your location on this app, right? So this is really efficient, passive, objective, and for my interest, low-cost measurement of high spatial temporal resolution data on health behaviors. This is where our participants live all across the US. But you know, importantly, we had 94% of our participants who wore, had at least one period where they wore the Fitbit for more than 10 hours a day for 5 days, right? So it's pretty good adherence to our study protocol. And we're left with tons of data, 6 million participant minutes of heart rate, steps, sleep, and GPS data, more than 2 million minutes of sleep in over 5,700 sleep bouts. And we were averaging about a GPS observation every 15 minutes. We'd set it up to ping every 10 minutes, let people turn their phone off or, you know, turn their location settings off. So we didn't get every 10 minutes, we got every 50 minutes, which is pretty good. This is kind of the richness of the data. This is one participant for 1 week. Purple's heart rate, green is steps, and this line is just latitude, which is basically, are we getting a GPS ping? But you can see the richness of the data here, right? You can see fluctuations in physical activity within a person, within a day, right? And usually how we get this information is we ask you to fill out a questionnaire every 4 years on your physical activity, right? And we say on average, you know, how much do you run per week, right? So we're not getting any of that information that we're seeing here. So this is a lot more detail. You know, we can see things also like sleep. Usually we ask on average, how many hours per night do you sleep, right? And we ask that every 4 years. Now this, we can get the actual duration of sleep, the timing of sleep, all sorts of, you know, things about sleep quality too. This is another metric of sleep. I know you guys maybe are not interested in sleep per se, but this is a 24-hour clock where each color is the heart rate over time. So we can see each color is a day, sorry, of heart rate. And the thick blue line is average heart rate. So now we can see kind of circadian patterns, like when are your most active periods, when are your least active periods. This gray shaded area is the Fitbit recorded sleep period. This is actually my data when I flew to California, and you can see my sleep period shift to match the local time zone. So we can see things about circadian patterns. You know, we can look at shift work. We can look at all sorts of things on sleep with a really fine objective perspective we've never been able to do before. But in terms of nature, so we also have this GPS data, right? So we can actually, this is my data commuting from my home in Cambridge to my office in Fenway. And now we can see, you know, actually where people spend time, see where they're getting exposure to different factors along the way. This is my data for kind of a whole week. And you can see my kind of monotonous travel pattern. But the interesting thing here is when I talk, what's that?
Got to get you down to our office.
I know. I almost got there today, almost. but the funny thing here is that what we do in most of our work is we look at just that, like, you know, 250, maybe 1250 meter area around the home. So that's basically, you know, the width of one of these circles, right? So we're really just looking over here when I had all this time spent in different locations, right? So this is a schematic of what we want to do and what we're working on now, where we have, you know, GPS data as a person moves through space. We have their activity level, so it's color coded each point by their level of activity. And then we overlay that on our, you know, NDVI data, for instance. So now we have a kind of personalized exposure metric to nature. So we can really look at truly how much time people are spending in contact with nature. as opposed to using this, residential address and making some assumptions. I won't get into too much detail here, but basically we're now expanding this to other cohorts using an app that was designed at Harvard. Basically, this app allows us to scale this stuff up for a fraction of the cost. And we get accelerometry data from the phone itself. So movement data from the phone as opposed to a Fitbit. And we've shown that it's a pretty good proxy of both physical activity and sleep from just your phone usage alone. Depressingly, most of us use our phone right before we go to bed and pick it up first thing in the morning. So it's a pretty good proxy. So this is really, really cool that we can scale this up without having to pay for Fitbits and send them to participants. We can just use a smartphone-based platform. We're also doing something called Ecological Momentary Assessment. This is just a fancy word for pinging people on their smartphones and asking them questions. For instance, right now, do you feel happy? Right now, what are you doing? Are you being physically active? Or were you sleeping, etc.? Things like that. How was your sleep quality the night before? So we can ping people and ask them these questions. And the cool part is that we have the GPS data in the phone as well, so that we can look at how spending time in nature is related to happiness or is related to other physical activity or other behaviors. So that is kind of a temporal link, right? So we can say, what were you doing? If you repeatedly answer that you're happier in green spaces, we can actually look at an individual level that you are happier, as opposed to saying people who live in green spaces are happier than people who don't live in green spaces, right? Now we actually get like a within person measure. And we have a few studies on over 3,000 participants where we're asking people questions every once or twice a day for 8 days, or longer term year-long studies where we're asking people every 11 days for them to report their happiness and just getting repeated measures over time. So we're also trying to do similar work with cognitive function. So incorporating this app that measures cognitive function into the app I was talking about earlier. So when people get a ping, they can actually do a quick cognitive test on their phone, like less than 3 minutes. And we can say, do you perform better cognitively in greener spaces? Or even if you've had exposure to green space, in the day prior to doing a cognitive test. So, going back to this diagram, you have all this GPS data. Maybe we say instead of physical activity, it's cognitive function in a given location, right? So that's the idea there. And then, I've said a few times about NDVI and the limitations with NDVI. So what we're doing now is we're actually tapping into, deep learning algorithms where people have trained them primarily for autonomous vehicles, but they've trained these algorithms to take any image and to be able to identify exactly what's in that image, right? So how can we use that for exposure assessment for nature? So image-based approaches to nature and health. I told you, satellite-based data tells us very little about the quality of a natural environment. Geocoded street level images, such as Google Street View, could provide us insight into specific natural environment features from an on the ground perspective as people view them. And then these machine learning approaches, they're a fancy way of just scaling this up. Like as opposed to me going through every image and saying, is there a tree in it or not? I can do this for hundreds of millions of images by using these algorithms to do it. So
have you looked at Treepedia at all? Have you come across them?
I've heard of Treepedia, but we haven't looked at it at all. No.
They're down the road from you at MIT. They've developed they do machine learning from Google Street View images and come up with exact locations of trees. And I think they were trying to transition that into like an assessment, like what species is this?
Yeah, now that you mention it, we actually indirectly are working. They're kind of I think Treepedia was kind of a spin-off of Place Pulse, which was this way of kind of ranking images, and we're using Place Pulse data where people would rank like the safety or green space quality or beauty, things that are purely subjective. So we are using that data. We had a meeting actually. Now that you mentioned, with one of the postdocs who's working with Treepedia, and I don't think anything came of it, but I'm not sure where they are now. One of the problems with MIT,
a lot of buzz a couple of years ago because they were ranking cities across the country.
Exactly.
Yeah.
So one of the problems with working with MIT, I find, is that they're very, they're super smart people, and they have these amazing splashy projects, but then they move on to the next one really quickly. So I'm like, I want to use their product, and they're like, well, everyone's left and gone to a startup, or they've moved on to their next thing. But certainly would be worth looking that back up.
Yeah, I haven't talked to them in years. I don't know where they
Yeah.
are.
Yeah. So anyway, with this Google Street View approach that we're taking, we go from this top-down approach to something like this, where you actually do see, from the ground, and we're able to use this PSPNet algorithm, fancy deep learning algorithm, that predicts down to the pixel level with like 90% accuracy at the pixel level of what's in a given pixel. And it can predict up to 150 different things. It can, tell the difference between trees and grass. You can tell the difference between sidewalks and streets. Some really, really useful data. So what does that look like in reality? How do we actually use this? So what we've done is we've created grids. So we've actually done a 100-meter grid for every street network in every city in the US now. We take a grid point, we pull the Google Street View images that are closest to a grid point. And this is just showing you, 2018 and 2017. It's the same location, looking at 4 different directions. So we pull that kind of near grid image, then we process those images. So this is taking that one location, 4 different directions, processed it, and then for each image, actually we average across all 4 images. But we get, for instance, this image was 23.6% trees, right? And we get percentages of grass and bushes and sidewalks and all these other things. So we can get at specific components of nature and see whether it's trees that are really moving the needle, or even looking at these different things and how they're related to noise or temperature or air pollution, and seeing which things are the biggest kind of drivers of those different environmental factors. So we've done this for Project Viva, and we're working on some papers there. Project Viva is a birth cohort based in Eastern Massachusetts. So we're looking at all sorts of different health outcomes there, and looking at Google Street View measures close to their addresses. But we're also thankfully funded a little over a year ago to do this for all the nurses health study cohorts that I've talked about today. So we've now downloaded 380 million Google Street View images dating back to 2007 for this 100-meter grid of all cities in the US. And we're hoping to, we're obviously going to look at this in relation to health outcomes in the nurses health study, but we're also going to hopefully be able to share that data with anyone. So if you guys want data from this kind of derived Google Street View images for the Boston area, we're happy to share that as well. So taking this back, we're going to link it to all these geocoded addresses, look at long-term health outcomes like cardiovascular disease. We're also going to take this GPS data, and we're going to, instead of NDVI, we're going to say, what is the tree view percentage? So for every point on your GPS data, we're going to say, what was your level of physical activity, and what were the percentages of trees within view, or what was the percentage of grass within view, right? So we can look at all these 150 different components of the built environment and see how they're related to physical activity levels. So any questions on that before I move on? I want to kind of talk about other interesting stuff. I know this is kind of methodsy and maybe a little boring, but.
It's really cool. It's not boring at all.
Okay, good. So
there's little nerds in this office, so you're preaching a good choir.
Okay, good. So now I want to talk about equity, COVID, and climate change in the context of nature, right? So in the green space literature, there's this concept of equigenesis, okay? And this is this idea that green spaces in lower income communities have a bigger effect than green spaces in higher income communities, okay? And what that means is that this is this landmark paper in the Lancet back in 2008, which showed that basically this is income group 4. I don't know why they set it up this way. These are the lowest income group, right, in the least green neighborhood compared to the highest income group, and you can see this big difference, right? So the incidence of cardiovascular disease was more than double for the lower income people compared to the high income people in very low green areas, but that difference is much smaller in very green areas, okay? So the gap between the wealthy and the poor in greener areas is narrower, right? And that's this idea of equigenesis. There's something about green spaces that decrease health disparities. Is there a question?
And yeah, those income groups are consistent between quintiles.
Yes, in this paper, I believe so. Yes. So the idea here is, why would this be, right? And there's kind of 3 concepts of why this might be. One is that people who live in lower income neighborhoods might be more reliant on their cars, right? Or sorry, people who live in lower income areas might not have access to cars. So they might spend more time in their neighborhoods, right? So it's actually a higher exposure. Second, higher income neighborhoods might, be more likely to have more, access to other amenities like private gyms or their own, private yards. And those factors might be more important, while lower income communities might be more kind of reliant on the amenities, public amenities in the neighborhood. And then finally, lower income communities might have higher levels of comorbidity. So they might be more kind of likely to respond to a change in an environmental factor, in terms of like they have higher to go to improve health. While if your health is already very good, it's hard to move the needle on improving it a little bit. So I think for those reasons, we do think of nature as a tool for health equity. And so, we've done some work on this, just kind of demonstrating the issue. We've looked at census, every urban census tract in the US, and looking at NDVI over time, so a 10-year period from 2001 to 2011. And this is a very fancy looking graph. Basically, this is the level of NDVI on the x-axis. And you can see here that very green areas are almost all white, right? So we see that green areas, mostly white people, and in very low green areas, it's much more diverse, right? So, white neighborhoods have greater access to green space, and this disparity has persisted over decades, right? So you guys may have read, some of the papers on redlining. They're very consistent that over the US's history, white neighborhoods, wealthy neighborhoods have much higher access to green space than lower income and more diverse neighborhoods. So this is kind of a fundamental issue. And if we're thinking about this idea of equigenesis or decreasing health disparities through green space, it's a really important thing to consider, that there's a long way to go here, right? So maybe this is a reason why health disparities persist. But I have to also speak about green gentrification. You guys probably talk about this a lot as well, right? This idea that, green infrastructure, urban greening is amazing. It protects us against climate change and improves health. But, a lot of these projects maybe overlook the negative impacts for vulnerable residents. And, low income communities, people of color, migrant communities have contributed the least to climate change, have had the least access to green space, most exposed to climate hazards, and have the fewest resources to adapt. They're also the most likely to be displaced from green infrastructure, right? So how do we improve green spaces? How do we green our cities without displacing people? My colleague, Isabel Angelovsky, I don't know if you guys are familiar with her work in Barcelona.
Oh, she's at that lab you told me about, right?
Yes. She's phenomenal.
Yeah.
She's she went to MIT. So a lot of her work is Boston focused, or her research. But now she's been in Barcelona for, I don't know, maybe even a decade. She's been there for a while. So, but I definitely think you should look up that group. I mean, you think you already work with one of the researchers there, correct?
James
Connolly, exactly.
Who's now there, who used to be at Northeastern.
Yeah. So, and I wish I had kind of a one slide that would tell you, okay, this is how you do it. But I think the answer is that it's really complicated, right? And even tree planting projects, there's been a lot of, case studies on people not trusting, people coming in and saying, I'm going to plant trees in your neighborhood. And so how do we do this in a way, and this is kind of an ongoing thing in my research, but in general, environmental epi, is how do you make changes to decrease harmful exposures and increase beneficial exposures in concert with the community, so they are playing an active role in making the decisions on what's being implemented, what their priorities are. And for instance, in green space, like if you're going to build a park, what amenities are you putting in that park? What are the factors in the park that you're going to build, and who are they for? Is this a top-down approach, or is it working with the community and actually seeing what they want? So I think it's probably something you guys talk about a lot, but I'm not sure. I'd love to have a further conversation about that.
I think it's something we need to lean into more. I mean, we've talked about it, and our work is always intentional, but I don't think we frame it as strongly as we should. We went to Eva, Joelle, and I went to a conference in Louisville last month, and the keynote speaker was, do you remember her name? The woman from the Bronx.
Oh, Majora Carter.
Oh yeah. Heard the
You know
name.
her?
Not
Yeah.
well, but I think I've heard her talk. But
She talked about, I mean, she had some really, she does more economic development, but does a lot of work around like green space and green infrastructure.
okay,
In the South Bronx, was it? Is that right?
Yeah.
And just gave a really compelling, amazing keynote.
great. I'll look her up. That's great. Yeah. So just to continue on, I think also green space and COVID. So I'm sure you're all aware during the COVID pandemic, when we were all locked down, we were so much more reliant on our green spaces. And I don't know what I would have done without having, parks and green spaces nearby just to walk around with my, 9-month-old daughter at the time. I think everyone understands this, right? Sorry, was somebody saying something?
No.
Nope. Okay. So I think it's also kind of interesting in a historical context that Frederick Law Olmsted, who is one of the famed landscape architects who designed the Emerald Necklace and New York Central Park, he back in the 1800s championed this concept of parks as lungs and espoused the two great natural agents of disinfection: sunshine and fall foliage. Right. So really, parks and green spaces have been a resilience measure for infectious disease before we knew what the germ theory was. Before we understood how infectious diseases spread, we fundamentally understood that there's something about open space and green spaces that we need for our mental health, but also for decreasing the transmission of infectious diseases. So I think we've shown that, and a lot of other people have done research on this area during COVID, where higher county level green space was associated with 6% decrease in COVID incidence over the first kind of months of the pandemic. And also, it was protected for COVID mortality in counties with high percentages of Black residents and higher population density. So I think, we understand, I think fundamentally that parks and green spaces are important. But I think it's really laid bare, this pandemic, first of all, it's laid bare incredible disparities, but it has also laid bare the fact that we need to value and fund these types of spaces and have them equally distributed across our cities, because they're not an amenity, they are fundamental, they're necessity. So we really need to reframe our thinking about green spaces as a perk or an amenity, and really they are a need, a right. And then nature and the climate crisis. So green spaces, maybe I don't need to even make this pitch, but green spaces have massive co-benefits for human health and the health of natural systems, right? So they're a major carbon sink. Planting 500 billion trees could capture 205 gigatons of carbon, reducing atmospheric carbon by 25%, which is enough to negate about 20 years of human produced carbon emissions, right? It's not enough. It's just one piece of the puzzle, but we need to plant more trees. I think that's a pretty obvious to address the climate crisis. You mentioned this, David, but substantial cooling in urban environments from green space, and then preventing soil erosion. We also need to think about wildfires, and I don't know if you guys talk a lot about wildfires in your work, but wildfires are not just an issue for the West, right? That air pollution, as you guys saw this summer, drifts east and affects all of us. In fact, there was a study that showed that in the modeling the air pollution health effects of wildfires, about 50% of the health effects are places outside of the West. Okay, because that air is drifting over major population centers across the entire U.S. It's not just living in the West where the wildfires start. You really have to think about this as a national and global issue. And then I think in the context of equity, we talked a little bit about equity, but how does nature disproportionately impact certain populations? Locally, I think that you've talked about this, but in the U.S., low-income blocks have 15% less tree cover and are 1.5 degrees Celsius hotter than high-income blocks, right? So we know that low-income areas are going to have lower tree cover and are going to have much higher temperatures during heat waves. And then, developing countries, we know, similar to this idea of green gentrification, the developing countries are particularly affected by the impacts of climate change because they're more vulnerable to the damaging effects of the hazard, but they also have lower coping capacity, and they've also contributed less to climate change. So it's another equity issue where green space would hopefully decrease those health disparities by, slowing the climate crisis might actually benefit those vulnerable countries first. So I'll kind of end there. My conclusions are there's a lot of research linking nature to health, but there's still a lot we don't know. These mobile health approaches will add granularity on how we interact with nature and give us some new insights. Deep learning algorithms applied to street level images will provide us specific time varying objective data on exposure to nature from really unprecedented perspectives. And then these data combined will provide relevant, actionable information for urban planners, landscape architects, policymakers, groups like you guys, to design communities that are optimal and equitable for health and help us address both the climate crisis and future pandemics to come. So this is just an acknowledgement to all of my co-authors and collaborators. My email address is there. You can also go to our website, Space Lab, which is an extra E there, or you can take a picture of that QR code and I'll send you to our website as well. But I really appreciated this opportunity to talk and would love to hear questions. So I'll stop sharing there.
Applause from Dorchester. That was amazing, and I don't know how much time you have, but there might be questions here. I don't want to make assumptions.
Yeah, I think. Well, first of all, I think I plan to be here till 1, so I have some time.
Okay. We also have to eat our soup.
Yeah, of course. Soup's important.
So, I mean, I have lots of synapses firing, not necessarily. That's my new favorite phrase.
Yeah, I said it like 5 times in the past 2 days.
Yeah. So, but I'm going to open it up to folks here for questions or thoughts.
I'm a bit curious about the study you said you started using with the children of nurses. Is that correct?
Yeah. Yeah. So we published. Oh, sorry. Go ahead. What was the question?
I'm just curious about would be curious to learn more about that.
Yeah. So, you can go online and read. It's actually called the Growing Up Today study. It's actually been going on since like the 1990s. So these were kids, some of them, they were about 9 to I think 15 when they were enrolled in the study. But because, we use this residential address data and we had information on their mothers, data from, 1989, some of them we've had information on their, location data from before they were born. So we have really, really rich data on some of these participants. And now they're like in their 30s. So it's kind of been this long running study. And we've moved to web-based and all this other stuff. We're trying to incorporate some of these mobile health technologies in these cohorts as well. But there's, I don't know, there's probably thousands of papers published on the Growing Up Today study. And we've published specifically on, green space and anxiety and depression. We published a couple of papers. If you look up the name Carla Bezold, Bezold, she'll give you, all sorts of, it's pretty cool. She's done some papers on green space and also blue space. Didn't see anything with blue space. But lots of work looking at that cohort as they kind of grew up and looking at incidents of depression. So looking at kind of when they were younger and whether they developed depressive symptoms.
Thank you. That's really interesting. I'll have to look up Carla B.
Yeah, another.
You just froze for a sec.
Lose you guys?
Maybe. We're still here. Hello?
Okay.
You back?
Okay, I can hear you. Can you hear me?
Yeah.
I'm back.
Yeah.
Can you guys hear me? Okay.
Yes.
Sorry, this new era is not. We haven't perfected it in the. My internet's better at home than in the office. It's kind of annoying.
Yeah. So you cut out when you talked about at the very end of Carla Bezold.
I was just actually saying that Carla is. You guys still there?
Yep. We're still here.
All right. I was just going to say that Carla, I think, is now the head of. Okay. Carla's the chief epidemiologist for the Detroit Health Department now. That's not
Okay,
wasn't necessarily a
got it.
needed thing, but she's doing some cool stuff.
So I had more like, I have a comment and like a bunch of loose thoughts. Is Marilyn here?
Yeah.
Yay! Hey, hey.
I'm ready.
All right, one more person just walked in. This is Marilyn. There's another chair behind Darrell, or you can grab, yeah. Marilyn is our social media outreach intern. And the camera's right there if you want to turn it, Peter.
Great.
Hello.
Oftentimes, Marilyn's on the wall.
Yeah.
They're coming from Tufts. So I just want to like say, damn, that's a lot of data. Like, holy moly! Like, and I'm sure you just gave us a taste of that, but there's like when we deal with data, we're talking about hundreds or thousands of data points, and to just see that number, I mean, that's impressive.
It overwhelms my brain.
I know. I'm thinking about like how we manage our data and like what it must take for you all to manage your data. It's just must be crazy. So
Yeah,
kudos
well,
on that.
it's funny. Thanks. It's funny you say that because I feel like we are so behind so many other groups that are, these computer science folks who can, manage much larger data. So we still have stuff to learn.
Well, it's impressive, and I think what's fascinating to me is how you recognize these shortcomings and you come up with these solutions to answer those questions. And clearly, you've put a lot of thought into it, and have a seems like a pretty experienced team of people who are able to manipulate and help actualize it. Which I think like coming up with an idea is one thing, but actually implementing it is another. We all come up with good ideas. It's like, how do you actually do them? Which I guess brings me to my next question is like, as you're talking about policy and things like that or implementation, I think there's an opportunity here, and we've been encouraged to really think more broadly in terms of incorporating health into our work, because when you talk about health, especially the policymakers at the state level, their ears perk up, because that is, if not the largest line item on their annual budget, right? It's one of them. So if you can demonstrate that planting a tree is cutting morbidity or asthma rates or whatever by X amount, all of a sudden there's interest in shifting money out of health related costs into other areas. So I would be very interested in whether it's a position paper or actually some research, or actually met with someone on our advisory board the other day who pointed me to an NSF grant, and I poked around a little bit. I'll share that with you as perhaps a way to start thinking about, what are the policy implications and the opportunities here to pilot something. You mentioned the Louisville study, which is I think the first of its kind. For those of you who don't know, and you'll correct me if I'm wrong, they're planting trees and essentially seeing how that affects heart disease rates.
And other outcomes. That is their main outcome. And I always tell them that's a really rough one to choose as your main outcome, because that's a pretty distal one. To hope you get that signal is going to be hard, but there's so many other factors in terms of mental health they're going to be measuring as well. Yeah.
And then thinking again on the term of scale. So, right, I think one of the things that I'm noticing in this field is like a tree takes 10 years to really give you benefit. What do you do in the meantime, right? How do you fund out for something like that? How do you measure that when you're doing these projects that don't work on the annual budget cycle? They work on a decade-long cycle or a 2-decade-long cycle. And I don't know if you have thoughts on that, or have seen novel ways to I don't know, to think about things on that other type of scale. And I guess like one of the ways you have is that data that goes back for decades, which is really amazing.
Yeah. So I apologize if my internet connection is unstable again, but I think that's exactly the type of thing we want to get at. Am I there still?
Yep. You might want to turn off your video.
Hear me okay?
Did you hear me? You might want to turn off
You
your
guys hear me?
video.
I just did.
Okay, perfect. Yeah.
All right. Yeah, so that is exactly the type of question we want to get at. Part of what we're trying to do is come up with more specific measures of nature, right? To use Google Street View things, but maybe there are other ways we can derive what hypothetical situations like a different level of NDVI represents, whether it's X number of trees, and we can look over time, through like tree planting projects to see what that kind of that lag is between the trees being planted and the health benefits using retrospective data, right? So data that's going back in time, as opposed to trying to look at this forward in time, because it's just too long. And we can model that so that we can get some idea of, okay, well, you plant X number of trees, this is what we see in terms of health benefit, and then put that into we call that kind of a risk assessment framework. But it's just basically taking these coefficients, these multipliers, right, and saying X number of people, you plant X number of trees, you expect this many cases of X, Y, and Z, and this is what we would see in terms of a different scenario where you plant more trees, you plant fewer trees. That is done. I mean, just to clarify, like for lots of other things, when we think about toxicity of food, when we think about air pollution, when we think actually about built environment stuff and transportation policy, we have these toolboxes that we use, and we plug, you basically plug in coarse numbers and you get an output, right? So we could start doing some of that work in a risk assessment framework and make that kind of tool available to you guys. Now, any critic would say that, oh, but there's problems with the model, it's not perfect because of X, Y, and Z. But what we always say is if we're not giving a number, if we're not bringing that information to the table, then it's not even considered, or it's considered that there's no effect, right?
Right.
So I do think that's something we hopefully can work on. We're in some conversations now with this Smart Surfaces Coalition, which is like a nationwide group trying to look at, primarily for climate change and cooling, but thinking about greening of spaces. But we're trying to incorporate the kind of health component potentially. It's early in the conversation, but I mean, that deliverable would be something that we'd love to share with groups. And it's always imperfect models, but again, if we don't have anything, then you really can't bring that to the table in a planning discussion, or even in a fundraising, or talking to the government about kind of the bottom line. I think actually that's one of the things we've done. I don't know if you've seen any of our health impact assessment work with the Metropolitan Area Planning Council.
No, I haven't.
Okay.
I don't know if
So I can send you, I think probably there's some links. So I didn't bring it in into these slides because it's not necessarily related to green space. But let me just send this to you really quickly in the chat. But we've done health impact assessment, which is, have you heard of that term?
Has anyone here?
I have,
Eva
yeah.
has. I haven't.
Okay, so it's similar to an environmental impact assessment where we have a planning decision or a policy decision, and we estimate what the health impacts would be under different scenarios, and it's all modeling, right? It's not based on any information like gathering data. It's saying, okay, well, here's what we anticipate to change, and we usually walk that forward to kind of a dollar value, right? So if you think that people, like we had there, the one I'm sending you, I think that link should work, but we looked at the MBTA service cuts and fare hikes back in, I think, like 2012, and we had transportation modelers look at kind of how people would change their behavior. We looked at how increased driving would be related to more sedentary behavior, more air pollution, more carbon emissions. We looked at kind of equity issues. We looked at all sorts of things, and then we put a dollar value on that to say if we expect more people to die of cardiovascular disease, then here's the value of a statistical life. And with all that information, you can say here's how much this decision will cost us in terms of health. Right, this is the cost of a hospitalization. This is the cost of X, Y, and Z. Again, all modeled, all kind of predictions, but you have to see the other side of the coin when you're making these decisions, because the META is just saying, look, we're gonna, we have a budget deficit. We've got to meet it somehow, but then the region is going to be paying for that in other ways, and so we want to put a dollar value on that. Similarly, I think for your scenario, it's like in terms of trees. If we don't plant these trees, what are the health effects, right? And here are the health benefits to planting trees. And so we can model that for a neighborhood, or we can even model that for the city of Boston.
Well, we definitely need to do that then. I mean, and I don't know, I'm just, I found the report. Thank you for that. I noticed here you worked with John Levy too, who I know a little bit.
Yeah, and BU is phenomenal because they have, I mean, I don't know if it's completely true, but at least they talk much more about action, and Harvard is, I think, much worse about action and much more about academic, publishing your papers and getting your grants. But we're trying to be better about it. And I think John Levy's work at BU now, he's really pushed people towards action and engaging, on the ground with stakeholders. And that is, being a measurable thing for your promotion, which is, this is how things happen at Harvard, right? If you do things that you can move forward, and if they care only about grants and papers, then you do grants and papers. But if they cared more about engagement and translation of research into practice, we would do more translation of research into practice. So I love the idea, and let's continue that conversation for sure.
Well, I can hear some grumbling stomachs here.
Yeah, no worries.
It smells so good with like the 5 different soups all melding together. So I wanna thank you, and just like leave a little space here for final comments or questions.
I mean, again, feel free to email me anytime. I'm happy to chat.
And when's the baby due?
February 3rd. So.
Well, enjoy the relative peace and quiet until you have one already, you said?
I have a 2.5-year-old. So yeah, so there's not that much peace and quiet, but it will be less.
You're gonna appreciate the peace and quiet. I have 2 kids. You're gonna just for the day, yeah. But it gets better. It gets worse.
That's what I anticipate. Thanks so much, and I wish I could be there in person. Hopefully we can do this again in person in the future.
Yes, I appreciate your time.
All right.
Thank you.
Thanks so much. Bye.
Bye.